Hello everyone, I hope you had a great week. We're here now near to the end, so we better get to continue with this so we can finish on time. So let's do number 10. The diagonals of a square ABCD intersect at point E. Okay, first of all, let's graph it. We don't have it, and we don't have the figure. We better graph it so we can understand better. So, graphic, here we go. We're talking about these diagonals. So let's do this and this. And they intersect at point E. So this is E, and then this is A, B, C, D. Now, BE is equal to 2x plus 1. So let me use this color. Equal to x plus 1. AC, okay, AC, the whole line equals to 3, 6x minus 4. Now, what is it the length of BD? Okay, now what I can get from this, wait, let me start over. Something important to remember is the properties of a square. Now, since we are not talking anything about angles, we don't need to worry about those properties, but we do need to worry about the side ones. Okay, the easy ones, all the sides are equal to each other, all the sides. Now, one that is not that easy, but it's really common to use is, oops, I'm sorry, it's just that I'm recording this earlier than normal, but let's continue. What I was talking about is that the other that are not as usual has that the diagonals are equal, so this side is equal to this side, and they intersect each other. They're perpendicular bisector to each other, so this side is equal to this side, um, this side is equal to this side, and they are equal. Since the two diagonals are equal, then the four sides that they form are also equal. And these are the important properties. Okay, let me do this in another color because it appears that they are equal to size, and that's not true. Yeah. So these are the properties we want. Now, we have the whole line, and we have only a portion of this line. Now, since these two are equal, I can say that DE is equal to BE. So this right here is also going to be 2x plus 1 because it's equal to BE. So the whole line will be 2, 2x plus 1 because we're talking about the two different, two small sides. Now that we have the two whole lines, we know those two are equal, we can say that 2x plus 1 equal to 3, 6x minus 4 because the two diagonals are equal. So let's calculate this. So this will be 4x plus 2, you know, the process. And then here equal, we know the process, so 3 times 6 is 18x, and then minus 12. Now we subtract 4x from both sides, and we add 12. So this cancels out, this cancels out, this is a 4. And we get 14x equal 14. Therefore, if we divide both sides by 14, we get that x equal 1. And now that we have the value of x, and we want to know the length of BD, okay, we already established that BD is 2 times, 2x plus 1. So we know that BD, oops, equal to 2x plus 1. So it will be equal to 2 times 1 plus 1 because x equal to 1. So 2 times 1 is just 2, so 2 plus 1. 2 plus 1 is 3, so 2 times 3. And this is going to be equal to 6. And that's the answer, 6 units. Better like this, yep. So let's continue. Okay, in rectangle, WXYZ. WY, so WY, the diagonal, equal for x minus 15. And XZ, XZ, the other diagonal, oops, is equal 3x plus a. Select all the true statements about WXYZ. So first of all, let's solve for x. Now, the same, we're not looking at the angle. You know, neither of these is about the angles and they don't talk about the angles, so let's concentrate in the property of the rectangles. Now, for the rectangles, this side will be equal to this side, the opposite side are going to be equal. So we have this, and then we can say that the diagonals are equal. The property of the diagonals is the same of the square except for the part that they are not perpendicular, they are just bisector. So they bisect each other and they are equal. So, I'm sorry about that. This diagonal is equal to this diagonal, and then these four sides are equal to each other. Now, if those two diagonals are equal, I can like make for x minus 15 equal 3x plus a. 3x plus a. So I'm just gonna subtract 3x from both sides and add 15. So this cancels out, and I have x equal a plus 15 is 23. And this is not true here because x equal 23 is not equal 7. Now let's see. WY equal twice QT. Now this is a conceptual, like we could do it mathematically, but it's gonna take too long. So based on that, what we can just say is that WY is the whole thing and is composed with these two little sides. Now, these two little sides, each of them is equal to XT, I mean, equal to this side. Now, if I put this side here, covers this, and if I take this side and put it here, it covers this. So I have two of this side, of this little side, pasted all over the line, and they cover all the line. So yes, this is true. Or we can just think about the property. So they bisect each other, so it means that these two sides are equal to each other, and vice versa, and they two are equal. You know, the diagonal completely is equal. So half of one diagonal will be as well half of the other diagonal, if you know what I mean. If not, you can look at videos that I put in the description that explain the property a little bit deeper. But just basically that. I put something that explain it better in the description, like more in detail. Now let's see CT, which is this little part, equal half of WY. This is basically what I just explained it. So this little side is equal to this little side. And this little side is half of WY. So yeah, this is true. We could also do it mathematically. It's just going to take too long. Now let's say CT. So CT equals TY. The same. It's the same property, 1 over again. And now they're asking about actual values. WY equals 77. So let's see. We know that WY is for x minus 15. So for x minus 15. Now x equal 23, so this equal 4 times 23 minus 15. 4 times 23 is 92, so this equal 92 minus 15. Remember, you have access to your calculator, so sorry about this. Okay, 4 times 23, 92. So 92 minus 15. So this is going to be equal to 77 if I'm not mistaken. Let's check. And here we go, 77. So therefore, WY, this is true. And now, since WY and XC, they are equal because this is a rectangle, they set it right here. XC is also going to equal 70. Yep. Now let's do 12. So didn't given parallelogram math, funny name, select all the three statements more or less the same. Now for parallelogram, they are talking about the angles here, so let's look at that. What we have is that the opposite sides are equal and parallel. So this side is going to be equal this side, and it's going to be equal, and it's going to be parallel. And now this side is going to be equal this side, and they're going to be parallel. Now the other thing is that the opposite angles are equal. So this angle equal this angle, and this angle equal this angle. And another thing, you can actually do it by the conjugate. I think that's the name. If I'm not mistaken, that's the name. For the angles, if you do this, these are two parallel lines, the two angles that are inside, or no, it's on the interior, so conjugate interior? I don't know if that's the name though. But the property is that the two interior angles right here in the same side, they add up to 180 degrees. Or you can just say that the adjacent angles in a parallelogram add up to 180 degrees. Either of the two, the easiest one for you. That actually rhyme. Either way, let's see what they ask for. Now that we established all the properties we know. Now they ask for x. And x is in the angles. And since we have the adjacent angles, we need to use the property that they add up to 180 degrees. So let's do that. So 6x minus 17 plus, oh, it's plus 17, I'm sorry about that. 2x plus 3. So this is plus 17. 2x plus 3 equal 180. So 6x plus 2x, ax, and 17 plus 3 is 20, so plus 20 equal 180. Now we subtract 20 from both sides. This cancels out, so we have ax equal 160, and we divide it by 8. I have x equal 20. Here we have our answer. This is not true. Now they're asking about y, and y is the sides, and we just establish that the opposite sides are equal, so we're going to make this side equal to this side because they are opposite. So 6y minus 13, yep, equal 32 minus 3y. Equal 32 minus 3y. So we add y, 3y to to both sides, and we add 13. So this cancels and this cancels, and we have 9y equal 32 plus 13 is 45. Now we divide by 9, cancels, and 45 divided by 9 is 5, so y equal 5. And here we have our answer. Oops. Better. And this is not true. Now they say measure of angle A. So angle A is equal to angle H, and angle H is 2x plus 3. So we say 2x plus 3. So angle A equal to x plus 3. We measure angle A equal to x plus 3. And we have the value of x, so this is going to be equal to times 20 plus 3. 2 times 20 is 40, so it will be 40 plus 3. And then this will be 43. And that's the value? Yes, we are right. Now t, okay, t will be equal to 6x plus 17. But a simple side, I can say that this is not the answer because they also, like t and a, need to add up to 180 degrees. So you can say either of the two. So you can say t plus a equal 180, and then substitute a by 43 and solve it. Or use the normal way. So you take 6x plus 17, some angle t equals 6x plus 17. This is 6 times 20 plus 17. This is 120 plus 17. And this is equal 137. And that's the value, which is not what we're looking for. And now they say MA equal 41. And MA is this one, is 6y minus 13. So let's do that. So 6y minus 13. We have the y is 5. So 6 times 5 is times minus 13. 6 times 5 is 30. 30 minus 13. And this is going to be 17, which is not 41. Yep. So let's go to the next one. Paulina bought a camping tent with a parallelogram shape like sheet as drawn below. If ACD equals 73, so it's okay, it's already marked. What is the value of x? Enter your answer in the box. So this is as like a say below, like before, and these two angles are adjacent. They are in the same side, one over the other. So they add up to 180 degrees. They are not equal. So let me do it. Okay. They are not equal. So I just need to say 6x plus 41 plus 73, because it's the value of the other angle, equal 180. So 6x plus 6x, we keep the value plus 41 plus 73 is 114. If I'm not mistaken, 114. Yes, 114 equal 180. So 6x, we subtract 114 from both sides. Equal 66. And if we divide by 6, this cancels out, and we get that that x equal 11. And now they asked for the value of x, so the answer is 11. Now I check because they might be asking for the value, I don't know, of angle D. And then we'll need to do it another way. Or we will need like to use the x, put it in the equation or whatever. But it's always better to check if they are asking for the value of of x, or they might be asking for the value of x plus 20. I don't know, there are some questions that are weird. So either way, the answer is 11. Let's see. One angle of an isosceles trapezoid has a measure of 53, where the measure of the other three angles of the trapezoid. Now, first of all, an isosceles trapezoid is something like this. And let's draw the angle property that we know. We know that this angle is going to equal this angle, because the two angles of the bases are equal, and then this angle, what do we call this angle? So if one of them is 53, then this one is 53. So this is the first thing. So let's discard any that doesn't have a 53 in there. Okay? And we get with these two options. Now, how do I know this angle right here? That's pretty easy. The adjacent, these two angles add up to 180 degrees because they are adjacent to the diagonal. They are like also the opposite angles as well, but they are in different bases. So this one and this one are to 180 degrees, and these two are to 180 degrees. So those combinations, but either way we can say this one is x and this one is x as well, and we have 53 plus x equal 180. We subtract 53 from both sides. Oops. And we have x equal 127. So these two are equal 127, and that's what we have here. And this is the answer. Now let's look at this. Segment CD is the mixed segment of trapezoid AEFB. What is the value of x? Now, for mixed segment, it is important to know that the addition of the two big sides divided by 2 is equal to the mixed segment. So 27 plus 2x minus 2, wait, okay, minus 2 over 2, so divided by 2 is going to be equal to the mixed segment, which is in this case 19.5. So the formula, I either see b1 plus b2, which is base 1 plus base 2, it's just the long sides, over 2 equal the mixed segment, or I see 1/2 of b1 over 2. It's the same thing. I just prefer to do it this way. That's my preference. So now let's solve for this. I'm going first to multiply both sides by 2. So this can cancel out. I also going to keep the 27, but 2 times x is 2x, and 2 times minus 2 is negative 4. You know, the same thing. In this side, since we cancel out the 2, I have 19.5 times 2, and this is going to be equal 39. Remember, you're going to use your calculator. It's just that it's easier for me to do it by mind. Now, 27 minus 4 is 23. So 23, 2x plus 23 equal 39. So we subtract both sides by 23. So this can cancel. We have 2x equal 16. And now, therefore, we divide by 2 both sides. This can cancel. 16 divided by 2 is 8. So x equal 8. Here it is our answer. They say, what is the value? They say here, what is the value of x? And here we go. Now, if they ask for the value of EF, it's just substituting the value of the x in there. Now, in the trapezoid below, NP equal 15. Select all true statements. Okay. NP is the mixed segment of trapezoid JMLQ. Okay. That's true because the mixed segment divides the two sides in equal parts, and they just say here, you know, this equal this. They just put it here, and these two equal these two. So yes, it is the mixed segment because it divides the two sides in equal parts. Now, MP is parallel to JM. Yes, because like all these three lines needs to be parallel. Now, these two are parallel by definition. And then the mixed segment also needs to be parallel by to them. So yes, with KL, yes, is the bottom line. So these three lines are parallel to each other. Now x equal 3, we don't know that, but we're going to calculate it. So we use the formula, we say 2x minus 2 plus 3x plus 2 divided by 2 equal 15. So these two cancels, minus 2 plus 2 is 0, then we multiply by 2 both sides. And these two cancel, so 2x plus 3x is 5x, and then 15 times 2 is 30, and we divide by 5. And we get x equals 6, since 30 divided by 5 equals 6. And nope, that's not the value of x. Now I say that jm equals 10. Let's substitute the value. So we have x equals 6. So 2 times 6 minus 2. 2 times 6 is 12 minus 2 equals 10. And this is true. JL, KL L equal 11. So I don't think so, but let's calculate. 3 times 6 plus 2. 3 times 6 is 18 plus 2 equal 20. So nope, this is not true. And let's go to the next one. Given isosceles, very important, trapezoid ABCD with diagonals intersecting at point E, select all the true statements. So, okay, isosceles trapezoid. So, if it is trapezoid, the two angles of the base, the two angles adjacent to the base are equal. So, those two are equal, these two are equal. Now, this side, okay, the two bases are parallel. So, this side is parallel to this side. And also, wait, let me make this the exact length. To this side is equal to this side. Okay, I don't know if you hear that. Okay, let's just continue. Since it is an isosceles trapezoid, just for isosceles trapezoid, the diagonals are equal to each other. But as I said, this is only for isosceles trapezoid, and as well of the other properties. Another thing that we might forget, but later we might remember, is that the sides, let me just, these two are equal to each other, and then these two, wait, are parallel. You know, these two are parallel, then these two are equal to each other. Now, based on this, let's see what are the true statements. So AB parallel to DC, yes. AD equal to BC, yes, I just said it. DV equal to CA, yes. DE equal to 1/2 of DV, no. This is easier to see by eye that this is not uh like a mix, bisector. They do not bisect each other. That's not a property of of a trapezoid. So this is not true. They do not bisect each other, and then AE equal dV minus dE. Now, this is another thing that I didn't say. This is true because this portion right here, okay, I don't know what color to use right now. This portion right here is going to be equal this portion right here. And then this portion here will be equal this portion here. Like the two little sides will be equal, and then the two bigger sides will be equal to each other. So AE is this side. If I say dV, the whole thing minus this side, dE, we get to EV, which is the little side that is equal to AE. So therefore, this is also true. And let's continue. I think I'm just gonna do this one. Finish for today. But still, we have a lot to cover. So let's do it. 18. Given isosceles trapezoid DEFJ with the F being okay, but like isosceles trapezoid. Remember all the properties we mentioned for isosceles trapezoid here. Given that DF, okay, DF equal 7x plus 24, e.g., let me use the same color. They are equal as we established before. I'm just gonna use the same color. Try to make it straight. Okay. E.g. equal 5x plus 38. And dm equal 18. So dm equal 18. Select all the true statements. So if dm equal 18, em equal 18, yes, we established it before. These two little sides are equal. So these two little sides are equal. Dm is equal em, so they are equal 18. Now, what I was saying, okay, this is where we left. Em is equal to 18. It's fine. Let's see the next one. Okay, here's something weird as well, game. Either way, let's see the next one. Is they say mf equal 36, and mf is this side. Now, to know the measure of that side, I think we need to solve for x. So let's solve for x and see what we get. Now, we established that these two sides are equal. So that's the reason they're the same color, basically. So let's establish these two as equal. Dx, 7x plus 24 equal 5x plus 38. So we subtract 5x from both sides. And we subtract 24. This cancels. And we have 7x minus 5x is 2x. And then 38 minus 24 is 14. Now we divide by 2. I have that x equal 14 divided by 2 is 7. So now that we have the value of x, we can calculate the value of mf. Oh, the value of x. Now, wait, let me repeat because I think my pronunciation was a little bit weird. Now that we have the value of x, we can calculate the value of mf. Now let's substitute the value. So 7 times 7 plus 24 because x equals 7. And so it will be 49 plus 24. And this will be 73, if I'm not mistaken. 49 plus 24. Oh, 24. 73. So yeah, this is not true. Now let's see. The F is the whole thing. We know that this is 73 now. Let me use another color. This is 73. I say that the F, the whole thing, is 54. Yeah, we can easily see that that's not the answer because NF, just this side is already bigger than 54. So, yup. Mg equal 55. Um, Wait, let me see something. DF equal. Okay. I labeled this wrong. Or maybe I just put things. I put this color over this. Okay, I think that I did all purple first. I don't know what happened. But the value of the x is for what we calculated here is for the whole, you know, diagonal. Because I was saying how this all can be wrong. But this is the thing. We say df, the whole diagonal, is 7x plus 24. So 73 is the value for the whole diagonal. And if we want the value for mf, we just say 73 minus 18. Which is because 18 is this little side. So 73 minus 18. I'm sorry for the mistake. So this will be 5. 5. So 55. Y is only one of. I think that I did something wrong right now because it's only one off for the. Oh no, never mind. This is the F. MF will not. Well, we didn't get 36, so this was wrong either way, as well as the F. The F is the value for the whole thing, which is 73. So let's just continue. Now MG. We know that this MF is 55. So MG is also 55. So this is true. EG. EG is the whole line. The whole line is 73. We just calculated here because this whole line was 73. Then this whole line is equal, so it must be the same. And this is true. Here we have our answers. Also, be careful when you're labeling. I don't know what happened there. I think I drew something over it. Either way, that's it for today. I'll see you guys next week.